So yeah, welcome everyone to our first AI Tech Workshop in the AI Community of Practice. Really appreciate you all being here today. This one is focused on how to utilize the open source Jupyter project for your research. So it should be a really good session, very hands-on, and we've got a great presenter and workshop facilitator to guide us. And his name is Joseph Reitano. He is an AI lead at the Center of Excellence within GSA, and he supports the COEs and the U.S. Tech Transformation Services work on helping federal agencies adopt and use AI. And prior to that, he was a veteran naval officer and DO researcher, and he spent some time at the Oak Ridge National Lab, and he's got a computer science PhD in computer science, focusing on mobile edge machine learning and artificial intelligence. So Joe, thanks so much for taking the time to do this workshop with us. And before Joe gets started, I also want to introduce someone on the TTS AI team who works on the AI Center of Excellence as well. Her name is Krista Kennard. She is, like I said, an AI lead within the Center of Excellence as well. And prior to that, she comes to us from IBM, as well as she's a CMU grad. So I will kick it over to you, Krista, and then we'll run the workshop. So please go ahead, Krista.
Yeah, thanks, Steve. So hello, everyone. My name is Krista Kennard. I'm here to support Joe. Joe is the main show, but I'm going to be your kind of question keeper. Since we're not using Zoom, I think that there's a little bit of it can be a little bit tricky to get questions in. So what I'd like to ask of each of you is write your questions in the chat, and I will be reading through the questions and curating them. And as we go through the workshop, I will be jumping in periodically to ask Joe these questions. So like Steve said, Joe and I work together at the AI Centers of Excellence. We are part of the broader TTS team. And here at the Centers of Excellence, we partner with agencies across the federal government to help drive IT modernization. And both Joe and I are partnered with different agencies helping drive AI projects. The point of today's show isn't to talk about AI COEs, but if you've got any questions about how the COEs work or how we fit into the broader TTS AI landscape, please reach out to me or Steve. We're happy to talk about that. So without further ado, I'm going to turn it over to Joe. I'm really excited for this talk. I know in my background as a data scientist, I've used Jupyter notebooks a lot. I think they're really relevant. And I know that it's something that Joe talks about and works on a lot with his partner agency through our Centers of Excellence. One final housekeeping note, I have posted the links to all of today's Jupyter notebooks in the chat. So I posted a link to Joe's GitHub, and then there's also a link to the Anaconda distribution, which Joe will explain a little bit more about in just a second. So Joe, I give it to you.
All right, thanks, Krista. All right, hello everyone. I'm Joe Reitano. I hope you're having a great day. Today we're going to go and provide an overview of Jupyter Notebook and the entire project. I'll show you Jupyter Notebooks and some preliminary examples. And then we're going to get into the more advanced version of Jupyter Lab. I'll showcase the basics of Jupyter Notebook and the lab interface so you can comfortably maneuver around the interface. I'll go over the basic projects that Jupyter are built upon. And then I'll discuss the rich display aspects of Jupyter, pulling in a variety of different media to help enhance your notebooks and tell your story. Then I'll discuss a little bit about math basics using MathJax and LaTeX. And then we'll move on to data wrangling, and I'll showcase some easy methods to get data in and manipulate in what's called data frames. And then as we have time, I'll showcase some plotting basics and show some interesting examples of Jupyter notebooks that I've come across. And then in the last 10 or 15 minutes, we'll try to answer any questions that you may have. So if you want to follow along, you can take those links, you can pull down my GitHub repository, and you can also pull down the Anaconda distribution. So let's get started. So you first might want to install your Anaconda distribution. And the reason why I recommend that, it's free and it's open source. And you can actually have all the modules you need to get started off with. And it does a good job of synchronizing all those modules. So you'll install Anaconda, and then you can test your build. So you can just go ahead and run it actually in your Python notebook to test and make sure you have the up-to-date version you wanted. And then you double check and make sure you've got the right Jupyter version you have. So you can run these directly in these what's called cells. I'll show you that a little bit more. And now if you've already downloaded Anaconda, you can just run conda update conda. It'll solve your environment and it will update it accordingly. So you see I'm using this little exclamation point here to run local terminal commands right here in the cell. Okay, so for Jupyter Basics, you can import some images. The Jupyter Project was founded from the IPython project. It exists and to develop more open source softwares and so open standards, and it's a great interactive platform. So you can go and check out the Jupyter website, and it'll talk a lot about the Jupyter Lab, which is the next evolution or next generation notebook interface. It has your standard Jupyter notebooks, which I'll show, and then Jupyter Hub for sharing. And they also have a new one for sharing even more and communicate results with something called Voila. So when I show here how I actually pulled in from their website those images, I can get the Anaconda distribution here. So Anaconda comes packaged with Jupyter, so it's easy to start with. Has Spider, NumPy, SciPy, Numba. Has Pandas for your data frames and a lot more. Dask for running on multiple instances or GPUs and coordinating those. Bokeh, HoloViews, Data Shader, Matplotlib, which I'll showcase. Scikit-learn, H2O AI, TensorFlow, and of course Conda. So as you can see, I use, again, commands launched by this exclamation point. I wanted to see, what I had in the image folder. And then I want to run it. Now I can run just HTML source directly inside. Boom, and I can control the size of the image as well. Now, notebooks are all over the place. So you'll see Jupyter built in Google's Colab environment. So here I uploaded one of my math notebooks so I could showcase it in Colab. You'll also see Jupyter Notebook in SageMaker Studio now. So this is an addition of Jupyter Lab. And then even Azure. So Microsoft Azure Notebooks, they use Jupyter under the hood. So everybody's using it. All right, and also the support for Jupyter Notebooks. They're up to about 137 kernels by my count. All right, so let's talk about its rich display. Interactive Python's really been growing, and the Jupyter Project has really taken on some serious steam in the academic environment. But also in business cases too, or within government. You can actually pull in some decent media, like I've done here with our Centers of Excellence, GIF or SVG. But if perhaps I want to take it and I want to make it smaller, I can just use HTML source to actually make it smaller and move it to where I want. So it's almost like a web page using Markdown language. In Python, objects are declared by their textual representation using this method here. So IPython expands on that idea and allows the objects to declare other richer representations. So HTML, JSON, PNGs, JPEGs, SVGs, and my favorite, LaTeX. So you have basic display imports, and it will use the best representation possible. And it usually looks pretty good, but you can also display a particular function to display it how you want it. You can assign it to a file name or a variable name and then call it. So it makes it easier for organizing. And then you can also pull in other websites. So for instance, you could pull in the tensorflow.org website, and you can play around with different neural network configurations, and you can actually run it within Jupyter Lab. You can also create links to local files by importing file link. So I find my files that I want to link to, and then I go ahead and create the file link command, and then I can just link on these, and then it opens up. So pretty useful when you're trying to do a workflow. You can also embed images from things like 511. Let's get the current display. You can embed these graphics. You could actually go ahead and see the latest traffic for your ride home. And you could just set up one page just with all of your images of your ride home with 511 cameras. You can also incorporate YouTube videos as well. This is one of my first ones that I've looked at to learn how to use Jupyter Notebooks a while ago. HTML, like I mentioned, you can import HTML, and you can create a table just out of HTML tags. And so there's your table right here. You can also do Wikipedia. So you can integrate some of these media imports. And then one of the ones that I just figured out not too long ago was mapping. So if you want to represent geographic information, geospatial data, you can add as an overlay. So some of these import features are actually pretty cool. So pretty feature rich for an open source, project.
Joe, this is great. So we've got a couple of questions to start before we move on to the next notebook. So you've already shown us a couple of notebooks. Can you tell us a little bit about who should use a notebook and how can they set it up kind of in their environment to be a useful tool for their project?
I think, this started really from, I think, developers in the academic environment. So you can use as a scientific notebook, basically. So you can put your math functions, and then you can code your math function, and then you can display it. But I see it now being used across government, different agencies. At the Oak Ridge National Labs, used a lot for machine learning, harnessing the power of the supercomputers, you name it. So, let's take, for instance, a workflow. Say you're at work and you're trying to identify kind of a tricky workflow within your organization and all the hurdles you have to get through. But, it seems like a large mess. So you can actually use one of these Jupyter notebooks to actually walk through each piece, each phase, break it down. In the CX community, it's called a journey map. So you could create a journey map, and then you could actually pull the actual data in that supports your journey map. And then you can start identifying or analyzing, doing exploratory data analysis on each segment to help solve your problem. So I think it can be just used for anything. And I've also seen it used for academic, for teaching, where the professors will take the notebook. They will take a series of notebooks for what they're teaching, actually set it up on Docker instances, and then give the students the Docker instances. It's all set up, ready to go. And then you distribute them. And then you have a version number for your Docker image. I've also seen it in a variety of instances, of course, dealing with machine learning and model development. So any other questions for that one? Because it's used pretty wildly now.
Yeah, that's helpful. And so also, just before we kind of dive deeper into this, for maybe some of the folks on the call who don't have a computer science or data background, can you maybe tell us the difference between what we're seeing here? What are the gray boxes and what's the white part? All
right. I guess I kind of skipped over the notebook basics. So let me go ahead and fire up from my command line, Jupyter Notebook. What happens is it's going to pull up the Jupyter Notebook, and this is just a simple Jupyter Notebook. I was in the advanced Jupyter Lab version. But with a Jupyter Notebook, you can fire up, say, these AI references real quick. All right, so I fired up my notebook. So let's go through and just talk about some of the different capabilities that are built in. So you have your initial file where you can create a new Python 3 notebook. You can open one, you can make a copy, save as, rename it here. You can download a variety, so a PDF or Markdown or a LaTeX or HTML. I use quite a bit. Inside each one of these, if you double click, it's a cell. This is one huge cell right here where I'm keeping track of all these AI references. But say I wanted to, and then of course the cells have different code. You can change it to code, but this one's a Markdown cell. So if you open up your first notebook and you want an interface tour, you can click on User Interface Tour, and this will give you the tour, and you can use left and right arrow keyboard keys to go backwards and forwards. So there's the file name up there. You can actually click in here and change the name. That's the menu bar, which I was just going over. Notebook toolbar shows you the different run cycles, adding a cell, copy, cut, paste. Here's your mode indicator. This is important. This isn't, you won't see this in Microsoft Word or anything, but this is a mode indicator. It has two modes. You're either in edit mode, which I'm in right now, or you can be in command mode, and that's when you usually run or display what you're doing. So we're in command mode right now, and there's edit mode. So you see the little pencil. So you can go to keyboard shortcuts. This helps a lot when you're working a lot and you're copy, cutting, pasting, doing a lot of work, running the cells. Here's your kernel indicator. So right now we're in a Python 3 kernel, and that's your kernel indicator. It looks like this when we're idle. That's when we're busy. And you can hit cancel to interrupt your progress. So if you've coded something that's not working out so well, you can just interrupt that kernel real quickly and restart it. And then you get a notification area. So you can just run that tour when you set it up. Pretty interesting right there. But I've grown to use and love Jupyter Lab. So there's the notebook. And then inside Jupyter Lab, you've got sort of this file folder. And then as I've been going across each notebook based on what I want to talk about. So I've figured out the basics and put them together in a pedagogic approach to introduce you to Jupyter Notebook. Any other questions?
That's helpful. Thanks, Joe. I think we're ready to go a little bit deeper.
All right, so I left off at mapping, which is pretty interesting. And next we're gonna talk about some math basics. So I love LaTeX. It's a great way to showcase mathematical equations because it's always been tough, in an academic environment to, really quickly create a math equation that looks good. Usually you're just handwriting it. But with LaTeX, it's really progressed a lot. And with the integration of Jupyter Notebook, you can really, format how you want things to look. So if you go to LaTeX webpage, you can learn a little bit more about how it's a document preparation system. It's not just about math, but a lot of people write their journals with it. So also you can, the browser symbols are used with MathJack's library, which incorporates LaTeX, but it can be used for all browsers. So a lot of this is browser based. So here's some of your math references when you pull down this notebook. So to create these equations, this is a beautiful equation here. This is a Lorentz equation. So here I just start with a begin and a line tag and an end and a line tag there. And then I do my equation inside. And then that renders really pretty like that. But you can also do it a couple other different ways. Like you can enclose with a $sign to display it in line. For example, that code might look like this and it will render like f of x equals x squared. You can also enclose LaTeX with a double $sign, and then that will center it. You can also enclose LaTeX code with begin equation star and end equation star as well. It'll look like that and render like this. I use the begin align and end align quite a bit. And then there's one last way to actually render it, and that's actually by calling the IPython display import display in math. So you can use the math function here to display. So I'll go through, I use this as a reference, but I'll go through some of these and just showcase how powerful this is. Here's Cauchy-Schwarz inequality. Really not too deep, but once you start learning some of these, like the summation and then this underscore, and you see the hat and the left and right brackets. Once you kind of understand that, you can start cooking with gas on your equations. You can do things.
How are you making it go from kind of that coding, like with your slash begin, to being rendered like this? What are you doing to make that gray cell go away so that it looks nice and pretty?
Oh, okay. So I just double clicked into the cell. And this is a markdown cell. See, it's denoted up here. I could turn it to code, but then I'd get errors. This is markdown. So we want this to be markdown. And then I hit either, if I want another cell below it, I'll hit Shift Enter, or I'll hit Control Enter with no cell. So I'm just going to hit Control Enter, and then it renders. Kind of easy, right? So pretty simple to maneuver in this notebook.
Yeah.
The identity of Ramanujan. These are just beautiful mathematical equations. Rogers and Ramanujan, Maxwell's equation. So for Greek lettering, you can go ahead and see some of these codes here: alpha, beta, gamma. Pretty simple. It's a language all on its own, right? So you can do limits, modular arithmetic, powers and indices. Aligning equations gets a little tricky. So you use equation, then align for the tricky one. So you can use a variety of tags. Fraction and binomials, continued fractions, multiplication of two numbers, easy. Roots, that's always fun. Sums and integrals. Now, sums and integrals are a big deal, you know, especially summations and products when you're dealing with data. So right here, I've got a little toy summation where you want to sum the values from 1 to 5. And then what's neat with Jupyter is you can go ahead and then you've got your math, you know what you're doing, and then you want to code it up. So here's a simple code for summation up to 5 of 5. Which is 15. Also, you can do the product really quickly. So you've got your equation, and then you've got your results. And the same is true for things like factorial. Really simple, which is really neat. And that makes it powerful, right? So you've got your math, you do your code, and then you share your result. And people do this on a really large scale. These are just toy problems. Now, there's also a number of different libraries you can use to pull and do the same thing. You don't have to do the coding. You could just call the library. So for SciPy, you know, you do scipy.math.factorial 5, NumPy. So they all have similar mods that you can go ahead and call. So we're just touching the SciPy ecosystem. So if you go to SciPy, you can see all the different packages involved with this to render math. Automatic sizing usually happens when you use the left and right bracket. So left and right. But you can also do manual sizing as well. And sometimes you have to do that. So you just use big, 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 right? So sometimes you need to do that. So like I said, I like to use this as a reference when I'm doing math. Matrices and arrays are big, especially when you're dealing with tensors or multidimensional matrices. You can format your math symbols. You can use accents. You can do colors, which is important too. You just go ahead and wrap that with a red or blue. All right, I'm going to leave most of this for you guys to pull down and take a look if you're interested. The other one I want to get to is the mean, median, and mode in data science, standard deviation, variance. There's a lot of things you can do. And then you can pull in the code for, say, RMSE. Okay, you can double click here and you can see, I wanted to showcase this. I didn't really want to run it. So I use 3 ticks and then I call the computing language and then I end with the 3 ticks and it showcases the programming language. So if you're teaching a Python course, you'd have a lot of that and then you'd have the students run underneath what they think they know. So you could actually compute RMSE right here in the cell. So I go on to do regressions, and then I have one toy problem I wanted to kind of showcase right here. So you can see I have a lot of reference material here. Okay, probability frequency distribution is always hard to explain, right? So you have 2 dice, and you want to just showcase maybe an array, right? So here's an array of 2 dice, and you see if you roll 2 dice and you get a 1 and a 1, you get a 2, right? And so this is a probability frequency distribution. So what you have to do next is you got to create a sum table. So you create a sum. So you get 2, a 3, you don't get 1s, right? You can't get a 1, but you can get 2 through 12. And then you have a frequency table. That's how many times you see a 2, how many times you see a 3, how many times you see a 4. Then you create a probability associated with each number, 2 to 12. And this is where you start seeing, oh, hey, I see 7s a lot. So probability is 1/6. So then you want to kind of showcase that. So you write what you're talking about, and then you want to import Pandas. You want to import this matrix into a data frame. So here we go. But the indexing is not aligned. So what you do is you take a look at the columns, and you see it's starting from 0, stepping each step to 6. So you get 0 through 5. And the same is true for the rows. But all you have to do to change the index is just go ahead and increase by 1. So now I've got the columns 1 through 6. And then next, I want to move the rows up by 1. So now I have the correct number of dice. So I have 2 dice, 1 through 6. And then you can see this frequency distribution table pretty well. So that's just a toy way to manipulate the data frame. Okay, so I have a lot more in here. I'll leave that for you guys to take a peek at later. Any questions from there so far? Okay.
Yeah, so we've got a question, Joe, that says, can you maybe go over your map again? Can you show us your map and how you brought it in into the Jupyter space?
Oh, it's already built in. So you get it for free. It's already built in. LaTeX is already built in. I'm doing this without...
Map. Sorry, your GIS map.
Yeah, I didn't have to pull in MathJax or LaTeX. It's already built in. So let me just go back one place here. Let me just show you what Jupyter, I think I missed it. Yep. So I forgot to talk about Jupyter Notebook is built on IPython, ZeroMQ, Tornado, jQuery, Bootstrap, and MathJax. MathJax is where you get your LaTeX, and you get it for free. You don't have to add anything. It's already built in.
I think the question is about mapping data, like
mapping. All right, so the mapping data, I did have to pull in an extra widget. I brought in Jupyter Leaflet. So if you go to the GitHub, you can kind of see and follow the directions of some of the different maps you can pull in. So you can also do take JSON data and overlay it. It's got a lot of primitives you can play with and widgets. You can do a split map control. So if you want to see the geospace 2 different ways, it's pretty interesting. You can display velocity data on top of the map. So if you're doing anything highly scientific in the meteorology space. You can also do a choropleth. And you can have widget control, where you can select. So say you're going to take in some COVID-19 data, and you want to overlay it for each country. You'd want to use something like this. Down below, you can see actually how to install it. So conda install. You can do a pip install. You have to do a Jupyter NB extension as well when you're using Jupyter Lab. So just follow those directions and you'll be able to do the mapping. I know, right? The map's pretty Gucci. I love it too. Any other questions?
I think we're good. Thanks, Joe. Let's keep going.
All right. So let's talk about Pandas. Now, Pandas is one of the ways that you pull in your data from a variety of sources and then you start wrangling it. So the way Pandas works in the standard import is import Pandas as PD. And it works just like any other column your data where you have a column and you have rows. So here, I'm going to write a file of just some old S&P data. I'm going to create that data. I'm going to check and make sure it's here. And then I'm going to load that data into, and see how you do it, pd.read.csv. It's pretty standard. So if you had an Excel sheet, which a lot of people do, a lot of people in government have it as well, you pull that data in and then you can start reading it just like this. Pretty simple to go ahead and manipulate data from a CSV into a data file. So say you just wanted to look at one data frame, which is really a series. You can go ahead and just call it df volume. Say I just wanted to look at the volume. If you wanted to call a row of data, you could use this location or indexing, 3. So I want to look at, March 1st data. You can also do describe, and we're going to see that a lot in TensorFlow next when I show you some examples with TensorFlow. But the describe command really helps to statistically describe what you're talking about, and it gives you your standard statistics little matrix. So you don't have to be a huge data scientist to just pull this data in. You might understand it sometimes, but that's a start right there. Now here's some of the versions you can pull in. You can pull in CSVs, you can pull in Excel, Parquet, HTML5, HDF5, JSON, GBQ, SQL, and there's quite a few more. And so it's basically read, whatever that is, and you can go to as well, right? So say I wanted to put out data, I would just say to CSV. All right, so I was playing around with some AI tools lists that we had created, and I just wanted to get an idea of how many we had and group them into capability type. So I read in our AI tools CSV, and I just wanted to look and make sure I had it. I just wanted look at a couple of the column types. So I just call the column types themselves in those brackets. A couple of different ways you can do that. But then I just wanted to count. I wanted to group by capability type, and then I wanted to count. So I got a listing of basically all the tools in our listing by their capability type. So really easy to count numbers if you get a lot of data. And so another example would be going to data.gov. So I went to data.gov and I just pulled down some weather data. So if you go here, there's about 211,000 data sets currently of all kinds of things. So I pulled that out and I went to the local weather archive of the town of Cary, North Carolina, because I just want to study the weather for that area. So it was so easy to pull the JSON data in and then read JSON into weather data frame, basically is what I called it. And then I wanted to list my columns just by the list keyword. I just want to see it across. I want to do exploratory data analysis. What are they using? What are some of the column names? What are some of the values? Are we missing any values? So quite a few rows of data to play with. And then you can use Booleans to ask a question. I want to know, did the town of Cary, have any snowfall whatsoever? So you can ask a Boolean to do that, whether or not it snowed. And then you can do weather counts for value. So you can do value counts of how much snowfall. So there's little questions you can ask it, and you can get, hey, It actually snowed almost 6 inches one time. So kind of interesting, and you can play around with that, and you can start doing prediction, but I'm not going to do that in this one. But all right, so we talked about Jupyter kernels. So I can do a thing. I can open up the Jupyter Wiki website for kernels and see all this data here. It's like a lot. It's not even numbered. I'm like, all right, how many are there? All right, so what you can do is you can just grab all this data. So I'm just going to grab it. Let's see if I can do this on the first pass. Dang, there's a lot. All right, I'm going to do a Command-C on my Mac. All right, I'm going to read the clipboard. So hopefully that comes in. All right, read clipboard. Boom, I just web scraped, and now I've counted 137 rows. So there's 137 rows, which means there's 137 kernels available to Jupyter Notebook. Then I can write. I can go to CSV. I can check to make sure it got written. So it's called kernels CSV. I can also just, again, check the column names. Maybe I don't want to see all those columns. I want to reduce the size. Maybe I just want to see the names. Or maybe I just want a specific one at location 10. I can also see a range of these rows from 20 to 30. Again, we slim it down a little bit. And now I want to just find the ones that support Node.js. And I can run a Boolean to ask it a question. And there it is. All right, so that's pretty much the basics of wrangling data. I've kind of showed you how to pull in some CSV, write to CSV, some JSON. And do we have any questions for that one?
Thanks, Joe. This is great. Can you tell us maybe what's the benefit of using Pandas instead of something like Excel or a Tableau or something for doing data wrangling?
Well, first of all, it's free. You don't have to spend any money for this. You can download it, start using it. Excel, from what I know, it still costs money. You've got to have a subscription. And Excel is very powerful, don't get me wrong. But you can also pull in Excel as a data point. So if you have a lot of Excel spreadsheets and you want to pull that in as part of a project, like I was mentioning in the journey map, I get a lot of Excel spreadsheets. I can pull that data in, pull it all into a data frame and start wrangling the data that way. So the one benefit is this is more, you learn about something, you apply it, it's interactive, and you can teach it back a little bit easier than just showing an Excel spreadsheet. And don't get me wrong, Excel, there's some Excel experts out there that can probably blow away what I just showed. But the key here is the open source nature of Pandas and the underlying technologies that support it, especially when you start getting into plotting.
Yeah, great. Thank you.
All right, so it's 2:40. All right, we're going to get into the basics of plotting. And the first one you'll find is Matplotlib. Matplotlib is a huge library to visualize with Python. It has a huge community. It has a lot of examples. You can do everything from lines, bars, and markers. I mean, it's just huge. There are so many libraries there. So that's a good place to start. In here, I've just wrangled a couple of these guys and showed you how simple it is to just go ahead and do a figure plot right here, how to title it. Here's a simple plot here. You can use this to arrange, show that. It gets more and more advanced as you go, but we could have a whole hour on just plotting and probably not be done. So here's some examples. I'm just going to briefly go through this. Let me get to some better Gucci ones. Let me see, I got one at the bottom. Line plots, scatter plots. Differences between group A, B, C with a histogram, and then you can do a scatter, and then you can do your line. Histograms are always great. Sine waves are cool when you're doing AC fundamentals. Confusion matrix, those are always wonderful. And then here's one that does local outlier factor. So this one gets a little bit more groovy. All right, I just want to show you that. All right, I've got a few more minutes left to kind of show you some example other ones. So here I am, I'm checking out this machine learning model analysis, and I want to describe it. So you can see how you've got sort of this mini workflow. And this is what a machine model kind of looks like. I wanted to kind of describe the numeric variables, the text variables, what they are, category variables, numeric cleansing. I just kind of walk through that. So it's a good way to learn about it, apply it, and then I have my little to-dos. I'm going to ingest some data, and I'm going to go through this entire function. This is a to-do for me, and get all the way to the end where we have a prediction. So this is sort of a to-do for me. Next one I wanted to show you was comparing anomaly detection algorithms for outlier detections on toy data sets. This one's pretty cool, but it's a lot of coding. You can definitely pull this one down. Robust covariance, one class SVM, isolation forests, local outlier factors when you're trying to find best fit for your anomaly detection. Another one that I'd like to show is the Lorenz system. This one uses the IPy widgets right here. So if you go to GitHub, you can learn more and then make sure that's installed. But this is the Lorenz system, otherwise known as the butterfly effect. And this is something that I don't see done in Excel, is you can play around with these widgets and describe the data a little bit better. So this is kind of fun to play with when you add your widgets, especially the mapping one. I can't wait to play with the mapping widgets. You can pull in TensorFlow. So if you do a quick course on TensorFlow, you can set it up to do a normal regression, and you can pull in the TensorFlow board, and you can actually work on this. And you can actually interact with this TensorFlow board. So pretty powerful. So if you're doing some research and you're working, I've never seen Excel be able to pull in this type of interactivity or this media. Once you've done some refinement, you can look at the tensor board again and look at your epoch loss, see which one's functioning better. You can see the learning rate. It's gotten better. That's a good example. So if you want to play with TensorFlow. Basic regression. I love how some folks put the links right here. So if you look at that, that is just HTML in a table. And then if you want to run that on Google Colab, you can log right in. It's going to fire up for you, and then you can run these. So it's running now. It's going to pull in, it's going to install Seaborn. It's going to do everything it needs to do. We won't belabor the point, but you can pull that down and play with this yourself.